Imagine standing beneath a mountain that weighs billions of tons. Now imagine engineers deciding to cut a highway straight through its heart instead of going around it. It sounds impossible, yet somewhere on Earth gigantic machines chew through solid rock every single day. But here's what nobody tells you. Building a mega tunnel isn't just construction. It's one of the greatest engineering battles humans have ever fought. Think about this. Some of the world's longest tunnels stretch for more than 57 kilometers, passing through mountains, rivers, and layers of rock formed hundreds of millions of years ago. Every meter forward reveals a new mystery hidden underground. One unexpected pocket of water or unstable rock can stop an entire project in seconds. And what happens next has surprised even experienced engineers. Most people picture a simple drilling machine, but the reality feels like science fiction. Modern tunnel boring machines, or TBMs, can weigh more than 4,000 tons and stretch over 150 meters long. Their rotating cutterheads grind through rock with relentless force, creating a thunder that echoes through the earth day and night. By the end of this journey, you'll discover how these mechanical giants reshape entire countries from below. Before a single meter of tunnel can be excavated, an incredible supply chain begins across continents. Steel comes from giant mills, cement starts as limestone pulled from massive quarries, and specialized cutting tools rely on some of the hardest materials ever discovered. Everything must arrive at exactly the right time because one missing component can delay a billion-dollar project. And this is where the story truly begins. Everything starts with limestone. Huge open-pit quarries in China, India, Turkey, the United States, and Germany blast millions of tons of rock every year to supply tunnel projects around the world. Giant haul trucks carrying more than 300 tons each transport the stone to crushing plants before it enters massive rotary kilns. Heated to nearly 1,450 degrees Celsius, or 2,642 degrees Fahrenheit, limestone transforms into clinker, the essential ingredient for high-strength cement capable of supporting mountains. Concrete alone isn't enough. Reinforcing steel gives tunnel linings the strength to survive decades of pressure beneath the earth. Iron ore mined in Australia and Brazil travels thousands of kilometers by rail and cargo ship before entering blast furnaces operating at nearly 1,600 degrees Celsius, or 2,912 degrees Fahrenheit. Inside the fiery furnaces, oxygen leaves the ore, molten iron forms, and new steel begins its journey toward becoming tunnel reinforcement bars and massive structural rings. Now comes one of the most surprising materials of all. The cutting discs that slice through solid granite aren't made from ordinary steel alone. Many contain tungsten carbide, produced from tungsten mined in countries such as China, Vietnam, Russia, and Bolivia. With a hardness approaching that of diamonds, these cutting tools survive crushing forces reaching hundreds of tons while grinding through rock that has resisted nature for millions of years. Most people never think about this, but water is one of the most important raw materials in tunnel construction. Millions of liters mix with cement to create high-performance concrete, while chemical admixtures carefully control how quickly it hardens. Waterproof membranes, synthetic fibers, and corrosion-resistant additives help tunnels survive groundwater, earthquakes, freezing temperatures, and decades of constant traffic. Every ingredient has a precise job, and removing even one could shorten a tunnel's lifespan by decades. Before excavation even begins, thousands of shipments have already crossed oceans and continents. Steel from Brazil, iron ore from Australia, tungsten from Asia, cement ingredients from Europe, and specialized electronics from Japan and Germany all meet at one construction site. The total material bill for a single megatunnel can climb into the billions of dollars, while supplies travel tens of thousands of kilometers before reaching the mountain. But the biggest challenge hasn't even started yet. The mountain waits in complete silence, but not for much longer. Thousands of workers, millions of tons of materials, and one of the largest machines ever built are finally ready to face solid rock. What happens next transforms engineering into something that feels almost alive. In the next chapter, you'll watch a mechanical giant bite into a mountain for the very first time, and that's when the impossible truly becomes reality. The moment has finally arrived. Instead of delivering one complete tunnel boring machine, manufacturers transport hundreds of individual components from specialized factories around the world. At the construction site, gigantic crawler cranes lift sections weighing over 200 tons into place with millimeter precision. Hydraulic engineers, electricians, welders, and software technicians work around the clock for nearly 8 to 12 weeks, transforming thousands of separate parts into one machine powerful enough to drill through a mountain. Imagine standing just meters away as the cutter head begins to rotate for the very first time. The steel face slowly reaches 1 to 3 revolutions per minute, but don't let that speed fool you. Hydraulic cylinders push the machine forward with forces exceeding 25,000 tons, while each cutting disc crushes rock under pressures greater than 250 megapascals, producing a roar that echoes through the tunnel like continuous thunder. What happens next surprised even experienced engineers. Every second, the rotating cutter head breaks rock that has remained untouched for millions of years. Depending on the geology, the machine advances between 20 and 80 millimeters per minute, removing hundreds of cubic meters of material every shift. You hear the grinding of steel against stone, smell freshly fractured rock, and watch clouds of fine dust disappear into powerful ventilation systems. Every meter forward feels like winning another battle against nature. But removing the rock proves almost as difficult as cutting it. High-capacity conveyor belts moving at around 4 to 6 meters per second carry broken stone through the machine and out of the tunnel without stopping excavation. Some mega projects transport more than 5,000 tons of rock every single day, enough to fill dozens of large dump trucks before sunset. Most people never think about this hidden underground transportation system. Here's the incredible part. While the front of the machine digs deeper into the mountain, the rear quietly builds the finished tunnel at the same time. Robotic erectors lift precast concrete lining segments weighing 6 to 12 tons each and position them with tolerances often tighter than 2 millimeters. In less than 30 minutes, a complete concrete ring locks together, creating a permanent structure strong enough to support the immense weight above. Even after each concrete ring is installed, the work isn't finished. Pumps inject high-strength cement grout into the narrow gap between the tunnel lining and surrounding rock at pressures of approximately 5 to 15 bar, filling every hidden cavity before the mixture hardens. The fresh grout feels warm as chemical hydration begins, creating a solid bond that prevents future movement and blocks groundwater from entering the tunnel. Then nature fights back. Unexpected underground water can burst into the tunnel without warning, flooding excavation zones within minutes. Powerful pumps capable of moving thousands of liters every minute immediately activate, while waterproof sealing systems and drainage channels protect both workers and machinery. Think about this. One uncontrolled water inflow could delay a billion-dollar project for months. Fresh air becomes another essential ingredient in tunnel construction. Giant ventilation fans push clean air through flexible ducts at speeds exceeding 20 meters per second, removing dust, diesel emissions, heat, and moisture from deep underground. Temperatures inside long tunnels can climb above 35 degrees Celsius, or 95 degrees Fahrenheit, making constant airflow critical for both workers and sensitive electronic equipment. Without this invisible system, excavation would stop almost immediately. Mega tunnel construction never sleeps. Teams rotate through 24-hour operations, often working 3 shifts every day to keep the machine moving continuously. Electricians inspect cables, mechanics replace worn cutter discs, surveyors verify alignment using laser guidance, and operators monitor hundreds of digital sensors inside climate-controlled control cabins. Every hour of downtime costs thousands of dollars, so every second counts. After months, or sometimes years, of relentless excavation, daylight finally waits on the other side of the mountain. But reaching the destination is only half the story. Before a single vehicle or train can safely pass through this tunnel, every millimeter must survive some of the toughest engineering tests ever designed. And that's where this incredible journey becomes even more fascinating. You might think the tunnel boring machine does all the hard work, but its true power comes from an invisible digital brain. Hundreds of sensors constantly measure cutter head torque, hydraulic pressure, vibration, temperature, and machine alignment every single second. Powerful computers analyze this stream of data in real time, warning operators before a small problem becomes a million-dollar failure. Most people never realize that today's tunnels are built as much with software as with steel. Imagine drilling for kilometers through solid rock while missing the target by less than the width of your little finger. Laser guidance systems project perfectly straight reference lines through the tunnel, while robotic total stations continuously measure the machine's position. The navigation system keeps excavation within a tolerance of about 10 to 20 millimeters, even after months of non-stop digging. It's like threading a needle through an entire mountain. As excavation continues, robotic systems handle many of the heaviest jobs. Automated segment erectors lift concrete rings weighing several tons with incredible accuracy, while hydraulic manipulators position each piece without hesitation. These machines never tire, never lose concentration, and repeat the same movement thousands of times with remarkable consistency. Yet every robotic action still depends on skilled engineers watching every detail. Now comes something that almost feels futuristic. High-resolution AI vision cameras scan every newly installed concrete segment, searching for tiny cracks, chips, surface defects, and alignment errors that human eyes could easily miss. Thousands of images are analyzed in seconds, allowing software to flag imperfections smaller than 0.5 millimeters. What happens next surprised even experienced engineers. Sometimes the computer catches problems long before anyone else notices them. Every concrete segment must prove it deserves its place inside the tunnel. In specialized laboratories, enormous hydraulic presses apply forces reaching several thousand tons to verify structural performance. Engineers also perform compression, bending, water permeability, and freeze-thaw tests to ensure the lining survives decades of harsh underground conditions. If one sample fails, investigators immediately examine the entire production batch. The tunnel boring machine itself also faces relentless inspections. Engineers measure wear on every cutting disc, inspect hydraulic seals, test electric motors, and monitor bearing temperatures that can approach 80 degrees Celsius or 176 degrees Fahrenheit during heavy excavation. Vibration sensors detect even the smallest imbalance before serious damage develops. Every inspection extends the life of machinery worth hundreds of millions of dollars. Think about this. Before the tunnel opens to the public, it must satisfy some of the world's strictest engineering standards. Projects commonly follow internationally recognized quality systems such as ISO 9001 for quality management and extensive structural safety requirements established by national transportation authorities. Every document, inspection, and measurement creates a permanent record proving the tunnel can safely serve millions of people for generations. But here's what nobody tells you. Even the smartest computers cannot replace decades of human experience. Veteran tunnel operators often recognize subtle changes in machine vibration or the sound of cutting rock before any sensor raises an alarm. A slight change in pitch, a different rhythm, or an unusual smell can reveal hidden geological conditions that software hasn't yet detected. Sometimes, the most advanced technology still depends on the instincts of a skilled engineer. Months or even years after excavation began, inspectors walk through every section of the completed tunnel one final time. Laser scanners generate millions of three-dimensional measurement points, confirming that the finished structure matches the original engineering design almost perfectly. Emergency systems, ventilation fans, lighting, drainage, communication equipment, and fire protection all undergo repeated operational tests before approval. Nothing gets overlooked. The mountain has finally surrendered, and the tunnel now stands ready to connect people, cities, and entire nations. But this engineering triumph is only one piece of a much bigger picture. Across the world, hundreds of mega-tunnel projects continue to reshape transportation, trade, and economic growth on an astonishing scale. And when you discover just how enormous this global industry has become, the numbers will leave you speechless. Think mega-tunnel projects are rare. Think again. Right now, hundreds of highway, railway, metro, water transfer, and utility tunnels are under construction across the globe. Governments invest well over $150 billion every year in tunnel construction and underground infrastructure, making it one of the world's largest engineering industries. Every new tunnel shortens journeys, reduces traffic, and connects communities that were once separated by mountains and rivers. China leads the world in large-scale tunnel construction, accounting for an estimated 45% of major new tunnel projects. Europe contributes around 20%, driven by ambitious rail links beneath the Alps and modern transportation corridors. Japan follows with approximately 10%, while India contributes about 8% as it rapidly expands highway and railway infrastructure. South Korea rounds out the top 5 with roughly 5%, proving that underground engineering has become a truly global achievement. Most people only notice the finished tunnel, but millions of skilled workers make these projects possible. Geologists study the earth before excavation begins. Mining crews, machine operators, welders, surveyors, electricians, concrete specialists, safety inspectors, and software engineers all contribute their expertise. Together, the global tunneling industry supports well over 2 million jobs, both directly and indirectly, creating careers that shape the future of transportation. Imagine building a tunnel in the 1970s. Many crews relied heavily on drilling, blasting, and manual surveying, making progress slow and unpredictable. Today's tunnel boring machines use GPS-assisted planning, laser navigation, artificial intelligence, automated segment installation, and real-time geological monitoring. Projects that once required decades can now finish in a fraction of the time while achieving far greater safety and precision. And this is where it gets truly extraordinary. Over the next decade, engineers expect rapid growth in underwater tunnels, high-speed rail corridors, smart utility tunnels, and fully digital construction systems. Future tunnel boring machines will use advanced artificial intelligence, predictive maintenance, and even more efficient electric power systems to reduce emissions and improve productivity. The tunnels of tomorrow won't simply connect places. They'll redefine how entire nations move. Did you know some tunnel boring machines are longer than a football field? Did you know the world's deepest transportation tunnels pass beneath mountains covered by more than 2,000 meters of rock? And here's the biggest surprise of all. Some of the rock removed during excavation gets recycled into concrete, road foundations, and landscaping projects instead of becoming waste. What once blocked progress now helps build the future. Today, you've traveled from giant limestone quarries and steel mills to the hidden world beneath mountains where engineering pushes the limits of possibility. You've watched machines weighing thousands of tons carve paths through solid rock while skilled workers and advanced technology transformed impossible ideas into reality. Every tunnel tells a story of patience, precision, teamwork, and courage that most travelers never see. The next time you drive or ride through a mountain, you'll know the incredible journey hidden behind those concrete walls. The next time you travel through one of these tunnels, remember that every meter represents years of planning, millions of engineering decisions, and the determination to overcome nature's greatest obstacles. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.